Hello, thank you for joining me for my lesson on standard deviation. Today's lesson is brought to you by coffee because everybody needs it. Um, Today, we're waiting for a few more people to show up. I just want to encourage you to check out the fourth quarter links. They can be found on the Canvas homepage as well as in modules. Lots of useful stuff. We're still doing assignments as normal. The assignments are going to be Canvas classwork as well as some Math Excel. There is an assignment link um, in the homepage as well as in the fourth quarter links on the modules. Also, if you need help with any of this stuff because you're just like, this isn't really going well for me, you can attend my office hours. Office hours are going to be from 1 to 2 every day. There is information on that in the Canvas homepage as well as in the fourth quarter links. So we're just going to sit tight and wait for everybody else to join us, and then we'll be right back. All right, so here we are. We've got two lovely students with me. Hannah, why don't you go ahead and introduce yourself?
Hi, my name is Hannah Tuiki, and I have fourth period algebra.
And?
My name is Ella Berenson, and I have fourth period algebra.
All right, so we got fourth period representing today. If you would like to be involved in a video, send me a note and I'll schedule you in. So without further ado, today we're going to talk about standard deviation and the empirical rule, okay? This is a pretty basic thing. Once you know what you're looking at, it's all going to be good. So if you haven't already, you should have your guided notes up and ready to go. So if we're talking about a data set that's like a lot of numbers, let's say we're talking about every single person who took the third PMA that we just finished, right? That's a lot of people. And frankly, more people than like I want to count. So what we do is we sort of say we're going to have this normal distribution that you see here, and we're going to assume that in this normal distribution, everything kind of goes from the average, okay? So if we say that the exact center of our curve, which I'm going to say is right there, is going to be our average, okay? Not the median, but the average. We can sort of calculate out from that normal curve there. So in here, we're saying, and this will all be given to you. So in this particular curve, we're saying that the mean or the average is 16. So in the very center, where most of the people are, we're going to say that value is going to be 16. And the other part that they'll give you is they'll give you what the standard deviation is, okay? So as it says in the text, a standard deviation represents the amount of distance away from the average, okay? So you can see a couple little ticks here. There's one here and here. There's one there and there. See how they're going out from the center. So if I know that each standard deviation is going to be 4, then on either side, what's going to be the value of one of those ticks that's just to the left or to the right of 16?
20.
Okay, why do you say 20 is going to be right here?
Because if you add 4 to 16, it equals 20.
Yeah, so Hannah, what's going to be on the other side?
12.
Okay, because?
16 minus 4 equals 12.
Right. And again, they're going to give it to you, okay? They're going to tell you what the mean is, and they're going to say a standard deviation is 4, so great. I'm just going to add 4 or subtract 4, and I get the next values out, okay? So then go ahead and fill in the rest of them. Garbage truck coming outside. All right, I gave you a chance to think about it. So if I'm going standard deviations down, okay, so one standard deviation would be 12. One standard deviation down would be 12. 2 standard deviations down would be minus another 4, and that would be 8. 3 standard deviations away on the bottom side would be 4. Make sense? And then on the flip side, 1 standard deviation above the average would be 20. 2 standard deviations above would be 24. And 3 standard deviations above would be 28. Make sense? Any
Yes.
questions?
Yes.
It's okay
No.
to ask questions. I'm sure other people might have questions. So if anything doesn't make sense, just go ahead and ask, okay? All right, so Hannah, this one goes to you. Suppose one of the data values is 20. So if I said, hey, I got 20 on my test, how many standard deviations is that away?
Is it 1?
1, and would it be above or below?
Above.
Okay, great. So I got 1 above. Excuse my bad handwriting. All right, and then Ella, if I said, hey, I got an 8. An 8 would be how many standard deviations away?
2.
Okay,
They're 2 below the mean.
so 2 below. That's just how we say it, 2 below. Right, so I got my 20 was 1 above, and then my 8 was 2 below. I'm counting away from the mean, just like that, okay? All right, now we can also ask questions like, if I had 1.5 standard deviations, okay, now I'm not talking about an actual number, but 1.5 standard deviations above the mean, what would the actual value of that be?
Would it be 22?
Why do you say 22?
Because you add 4 and then 4 divided by 2 is 2. So you do 4 plus 2 equals 6, and then you do 16 plus 6.
Yeah, exactly. Okay, so I'm gonna see if this actually works here in a different color. So here's 1 standard deviation, and then I have to go another half of a standard deviation away. Is that what you're saying?
Yes.
So I have to divide this whole thing, right? So I went 1 standard deviation, which is 4. And then I have to go a half of that, so another 2. And 4 plus 2 would be 6. So the value of the observation is going to be 16 plus I went 6 more, and that's going to be 22. Good job. Okay, so that's all the basics. Okay, now here I'm going to show you what the empirical rule is. It's this really cool thing. It's actually something that you probably ooh, that was interesting. Okay, you're probably really I know I have a lot of gifted students in my classes, and believe it or not, the empirical rule is really important for like curving test scores. It's really important for like, this is how you are actually staffed as gifted. If you are gifted, now you're going to know why. Okay, so the empirical rule states that if you have a normal curve, right, and our average or our mean is always going to be right in the center, this states that 68% of all the values in the curve are going to be within 1 standard deviation from the mean, okay? That could be 1 standard deviation above or below, okay? So what that means is between 1 standard deviation below and 1 standard deviation above the mean, which is what I just marked up there, 68% of all the values are going to be within that range, okay? This is sort of like when people say like, oh, it's an average score because 68% of the people got it. That's because they're within 1 standard deviation. Now, if you go out to 2 standard deviations away, I'll try to do that a different color here. Let's go back to red. So 2 standard deviations away is going to be 95% of all values. Okay. That means, so if you're thinking about like a curved test score as an example, and you say, okay, well, you know, if I was within 95% of what most people did, maybe that means I got like a score that's way up here, or it could have been a score that's way down there, okay? And then finally, 99.7 of all scores are going to be within 3 standard deviations. So that's this all the way down here to all the way up here is going to represent 99.7. Oh geez, this is going to get messy. Still trying to figure out how to use this thing. So 99.7. All right, so I mentioned like as an example, like gifted scores, right? So like for those of you, you know, back when you were in 2nd grade, if you've been in Orange County long enough, you took a test that you probably forgot about. And if you scored an average score, you'd be right in the center of this little curve here, right? Now, if you were 1 standard deviation above the average, you'd be right about here. And that means you did better than like this middle 68%. Now, gifted scores are always going to be 2 standard deviations above the mean. Okay, that's kind of the statistical mark of somebody who did really, really well. They're 2 standard deviations above the mean, which means you did better than the 95% that represents this whole middle. You're way out here. Okay, so congratulations to you if that's you. Consequently, this is also how they figure out like who gets a 3 on the FSA or who gets a 4 on the FSA or something like that. Okay. Girls, any questions so far?
No. No.
Okay, so if you're going based on this model, I'm going to ask you some random questions, and there's one tricky one. So just beware, there's going to be one coming at the end. So if I said, let's see, is there, oh yes, there is a question down here. Okay, so let's go down to task number 1. And we're going to use this idea of like 68% in the middle, then 95% a little bit further out, and then almost everybody 99.7% for the rest of it, okay? So take a minute and read task number 1. My first question is going to be, what value belongs right in the center of this curve, and how do you know?
16.2, because that's
do you
the
know?
mean. It's the mean, so it's the average.
Great. So mean is always going to be right in the center. You got it. So that's 16.2. Hopefully I can get better at drawing on my touch screen. All right, now let's go out a little bit further. So if I'm going 1 standard deviation above the mean, what's my next value going to be?
They're going to be 16.3.
Yeah, why do you say that?
It's because it has a standard deviation of 0.1 ounces, so you add 0.1 ounces to 16.2 ounces.
Beautiful, 16.3. If I go up 1 more, how much is it going to be?
16.4.
Yeah, we're just going to keep adding 0.1, right? All right, so Ella, let's say I'm going down now. What do I do here?
It's 16.1 because you subtract 0.1 ounces.
Awesome. And then if I go down again?
16.
And so on and so forth, okay? Okay, so let's start with answer, let's start with not number C, but letter C. If I'm looking at letter C here, it says approximately 68% of the bottles have between what and what ounces of water. Well, I'll go ahead and start on this one. Okay, I know the middle represents the 68%, right? 1 standard deviation away from the mean represents my 68%. So 68% of the bottles have between which 2 values here?
16.1 and 16.3.
Right. Okay, that means that's the majority of the bottles. 16.1 and 16.3. Make sense so far?
Yes.
All right, so the next one out, Ella, what percent, sorry, if I'm thinking 95% of the bottles, what do I got there?
Then you mean like what?
The
What would
middle
be 15?
95% of the bottles are between which two values?
15.9 and 16.5.
So the next one's out, 95% is 2 standard deviations
Oh,
away from the mean.
95.
That's okay.
Okay, 16 and 16.4.
Yeah. So if I go out one more, I get 95%. So I got 16 to 16.4. And if I went out again, right, like this isn't a question there, but if I wanted to go out one more and do like the whole 97 or 99.7%, I'd add one more and subtract one more, and I get that, okay? So here's the tricky one for you. Question is, what percentage of bottles contain more than 16.4 ounces of water? All right, so we're gonna have to do a little math here. Think about it, see if you can figure it out.
Would it be 16.6%?
16.6 would be the ounces, and I totally agree with that. However, this wasn't asking for the ounces. This is saying what percentage of bottles, which is a different question.
I divided the 99.7 by 6, which is like the number of deviations.
Ooh.
So.
Okay, that's a really good idea. Okay, so this is exactly why I love having students with me when I'm trying to do this, because I can't imagine doing a video lesson without getting these brilliant ideas. All right, so Ella, you're saying you're going to divide something?
Yeah, 99.7 divided by 6, because there's 6 deviations.
Okay, that's very, very good. Okay, so let's think about this idea of division, okay? So if I know that my mean is here, and if I'm 1 standard deviation away, that's 68%, right?
Yes.
So we're gonna kind of work backwards to figure this out. If I know that the middle 68% are 1 standard deviation away, tell me what percentage is gonna be between the middle and 1 standard deviation above, if you see what I wrote here, right?
Is it going to be 34?
Yeah, why would it be 34?
Because half of 68 is 34.
Yes. Okay. So I totally get why Ella's thinking I'm going to have to divide, because I got like some sections of standard deviation there, right?
Yes.
So here's where it gets tricky, okay? The next standard deviation up represents 95, right?
Yes.
So what that means is I've got like, well, let's start with what's the difference between 68 and 95?
27.
Okay, so 95 minus 68 equals 27, right? So here's the problem. That 27 of difference has to be split. Why do I say that it has to be split?
Because there are different amounts that it has to be split. Like, well, there are two deviations that would have that.
Yeah, the 2 deviations. There's one below and there's one above, right?
Yes.
So I like where you were headed earlier, Ella, when you said I was going to divide by 6. But the
Yeah, I
thing
see
is,
why that's wrong.
but each deviation, even though it's worth the same value, it's not going to be the same percentage. Okay. So we have to
Okay.
do a little bit of extra math to figure out percentages here. Okay. So if I know that 27% is going to be combined into this section and this section, how much is just that section going to be worth?
27.
Well, remember, I got to take the 27 and split it between the above and the below,
13.5.
which is half of 27, right?
Yes.
This is statistics, baby. That's what I'm talking about. All right, so let's do it again. Okay, the next deviation out is going to be 99.7. Okay. So if I go another deviation out, well, for starters, I'm wondering 99.7 minus 95 gives me what?
0.7.
4.7.
Wait, 2.7.
And that's 4.7.
Yeah, 9 minus 5 is 4. Okay.
Yeah.
All right, so remember, I've got a difference of 4.7, but I've got to split that difference between the upper and lower deviations. Right? So what's that
Yes.
going to be?
2.35.
All right, so 2.35. Whew, that's a lot. Okay. Oh no, I lost it. 2.35. So, bringing it back to, if you're like 2 standard deviations above the mean, technically what that means is you are in the top 2.3% of anybody who took a test, right? These are like your level 5s, right? So if you got a level 5 on the FSA, 2.35%, pretty awesome. So if we're getting back to our actual question now, we did all that work to go back to D here. And if we said that the percentage of bottles that contain more than 16.4 would have to be anything that's above that second deviation, right?
Right.
So the percentage of bottles, wait, is it 16.3 or 16 point?
60.
Oh yeah, it is 16.4. Okay, so our final answer there is going to be 2.35%. Because again, we had to take our total percentages and we're splitting it between the two, the upper deviation and the lower deviation. Gets a little complicated, but if you draw it out, it makes it a lot easier. All right, so you guys, let's try it on number 2. All right, I'm gonna go, while they're thinking about part A, I'm gonna go ahead and think through how this looks here. Okay, so if normally distributed, that means I got my normal curve, and my mean is 510, that's right in the middle. Standard deviation of 80, so I'm gonna go up 1 and down 1, and I'm gonna either add or subtract 80. So I got 590 here, and I got 430 there. Okay, so I know that the middle percent, what was the middle percent again? I forget.
68.
68.
Yes.
Okay, so the middle 68. All right, so this is tricky because it's saying what's the probability that a score is going to be up here. So how are you going to figure out what's just above but not below?
Well, 95% of the scores are above or below that, so you'd have to divide it by 2. Wait. No, you divide the 95% by 4 because you don't want what's in the middle or below.
Mm-hmm. What do you think about that, Hannah?
I can't hear it. It's like breaking up.
Oh, it got garbled? Okay. All right, well, the tricky thing is, again, if this 68%, I've already kind of counted them because they're already in the middle. So I don't want to count that 68%. I only want to think about what's left. So if I've already counted the 68%, how much percent is left?
So it would be 95 minus
Not 95.
68. Well,
I
it'd
got a
be,
whole 100% that I used.
oh, okay.
Mm-hmm.
It would be 1.5.
Okay, you're going
No.
2 standard deviations above.
No,
I think.
I accidentally divided, not so
Oh, okay. So if I have 100% that I started with, and I took out that middle 68%, I've got 32% left, right?
Oh, okay. Yeah.
But remember, I've got some of that 32% that's above, and I got some of that 32% that's below, right? So if I only want
Yes.
the 32% that's above, what do I need to do?
Divided by 2.
Divide by 2, okay? If I divide it by 2, then I'll know exactly how much percent is going to be above, which is 16%, and below is another 16%, and together that's the remaining 32% that I didn't already have. Some tricky stuff, man. All right, so part B looks like it went pretty far out. Let's go ahead and build out the rest of our curve here. And let's look at part C really quick. So if I did 1 standard deviation, I got 430 and 590. If I did 2 standard deviations, what would it get?
You would get 350 and 670.
Okay, so that's kind of what I was thinking. All right, so if I'm 2 standard deviations away from the mean, I got the 350 and the 670. So what percentage of scores are within 2 standard deviations?
95%.
95. That's straight out of the notes in the empirical rule that's above. And then this part B question is just like the other question. Okay, so if I just want to focus on what's above 670, well, I know that 95% of the scores are within this, which means how much is left? If I've already done 95, how much percent do I have left?
47. Wait, what was the question?
So for part, sorry, I'm jumping back to part B now. So for part B,
Okay.
if I've already accounted for 95% of my scores, how much percent do I have left?
5%.
5%. And I know that some of that 5% is going to be above, and some of that 5%, like up here, and some of that 5% is going to be down here. So how do I figure that out?
5 divided by 2.
Divide by 2. 5 divided by 2, and I get 2.5%. That is standard deviation in the empirical rule. Okay, it's all based on the distance that you get away from the average score. Okay? Girls, any questions?
No.
Okay, I know it's a little tricky, but you did a great job on it. Now, I gotta ask, let me do a quick reminder. Make sure that once you're done viewing this lesson, you go and you do the Canvas classwork, and the next day there should be a Math Excel available. But just focus on the Canvas classwork. Math Excel, I really get into that more next week. Please keep tuning in, and if you're interested in becoming a guest on the show, you just let me know. So, Hannah, do you have any shout outs before we sign off here? Okay, she's too shy now. Oh, you muted yourself. Let me unmute you. You're still muted. Okay, let me see if I can figure out how to unmute you. Ella, do you have any shout outs?
No.
No fourth period friends you want to say hey to?
Hi. No, I don't want to say hi to any of them.
All right, Ella doesn't like anybody in fourth period. Just forget them all.
Well, no,
Hannah,
I'll say hi to Scarlett and Alexa.
All right, there we go.
Okay.
Hannah, I think you got to take out your headphones because I can't unmute you with your headphones in. Well, sorry guys, Hannah is now frozen. I'm not sure what the technical difficulties are, but I will say thank you all for hanging out, and we'll see you guys next time.